So today we're going to cover 7.5 from our book, The Sum and Difference Identities. The main ones we'll focus on are sine and cosine. I'll also go into tangent a little, but for the most part, sine and cosine will be the emphasis of our class, but there are other ones. So basically what you guys need to understand is that this is not legal. You are not allowed to say that the cosine of A minus the cosine of B is equal to the cosine of A minus B like this. That is illegal. There is no distributed property for cosine in that fashion. So the identities, if we were in a classroom, I might try to kind of show you where they come from, but for now, let's just kind of learn them and see how to make them work. So for cosine of A minus B, we have, this can be rewritten as the cosine of A, cosine of B, plus the sine of A, sine of B. So this is the sum or difference angle for cosine of A minus B. Now we can do for cosine of A plus B, we have cosine of A, it'll be the same exact thing, cosine of B, but now we put a minus sign, sine of A, sine of B, okay? So the way we oftentimes use these are actually used to build other identities, but what we're gonna do right now is we could see, well, what if somebody asks us to find the exact value of cosine of 15 degrees? Let me write this better. So not using a calculator. So if they ask us to find the exact value of cosine of 15 degrees, well, we don't know the cosine of 15 degrees based on our unit circle. But what we could do is we could say, well, 15 degrees is really the cosine of 45 degrees minus 30 degrees, right? That would still be 15 degrees. Now, why did I choose 45 and 30? Well, I chose 45 and 30 because I know a 45-degree angle for cosine, and I know a cosine of a 30-degree angle as well as the sine and the tangent, okay? So the thing is I guess I could have also chose 60 degrees minus 45. That would have given me the same answer. It would still have been 15 degrees, but I just chose this one because it was the easiest one to work with. So what I'm going to do is I'm going to use the cosine difference formula above cosine A minus B. So this will be cosine of, oops. Now here, this is now my A, and this is now my B. So when I write my formula, I get the cosine of cosine of 45 degrees, cosine of 30 degrees, plus sine of 45 degrees, sine of 30 degrees, right? So that's not so bad because the cosine of 45 is square root 2 over 2. The cosine of 30 is square root 3 over 2, plus the sine of 45 is square root 2 over 2, and the sine of 30 is 1/2. So now we can clean this up and we get square root of 6 over 4 plus square root 2 over 4. So this is the square root of 6 plus the square root of 2 all over 4. Now I have seen sometimes in the book, I'm not sure if they do this in the online homework, but sometimes in the book when you're doing it from the actual book handwritten, they factor out the square root of 2 and do it as a square root of 3 plus 1 all divided by 4. So make sure you can do that as well. But this is also a correct answer, but you have to answer it in the way that the computer asks on the exam, okay? So get some practice on the homework doing that. Let me have you guys try one. So let me give you the cosine of 75 degrees. So take a minute, pause the video, and see how you guys would set this up. Okay, so hopefully you did the cosine of 30 degrees plus the cosine of 45 degrees. Well, you know that that is really the cosine of 30 sine. So if we look up here, cosine of 45 plus sine of 30 sine of 45 degrees. So everything will end up being the same. This will become square root 3 over 2. This will become square root 2 over 2. But now it'll just be a plus. This will become 1/2 times square root 2 over 2. So we should get the same exact answer, I believe. We'll get square root of 6 plus square root of 2 all over 4. Oh, did I change it to, oh, I'm sorry. Because this is a plus, that means I have to use a minus in the middle. That's when I was wondering why it was wrong. So you notice the formula, when you have a plus sign, you have to use a minus. So just keep that in mind for the cosine ones, okay? Let's see here. There's also, I could ask you to find the cosine of s plus t when or if sine of s equals 2/3 and sine of t equals 1/3 negative. Okay, so first of all, we have to figure out, let me see here. Oh, and it says assume S is in quadrant 2 and T is in quadrant 4. Okay, so they're giving us some information. So they told us the sine and the sine of S and the sine of T. But technically, if we know the sine of S, right, and it's in quadrant 2, that means we have something like this. So we have this triangle. And again, drawing the unit circle or drawing the circle with your triangles really helps you kind of understand what you're doing. Okay, so we have that. So then if this is the angle S, we have to then say that sine is so opposite over hypotenuse. So the hypotenuse is 3 and the opposite is 2. So then we have to do 9 minus, I'm sorry, I'll write it out. 2 squared plus b squared equals 3 squared. So b squared is equal to 9 minus 4, which is 5. We square root both sides. So we have b is equal to the square root of 5. Right? And I believe we should put a negative there just to remind ourselves of that. Now, if we do t they say is in quadrant 4. So then we're going to have this triangle. And that's now t, right? This angle right here. So let's see here. Negative 1/3, so that would be opposite. Negative 1 over hypotenuse of 3. So we would have 1 squared plus b squared equals 9. So b squared equals 8. So b equals 2 square roots of 2. So this would be 2 square roots of 2, but in this case, it's positive, okay? So let's come over here now, and we know that this is going to equal the cosine of S, cosine of T, minus sine S, sine T. So the cosine, so now I'm looking at this right here, this triangle. So the cosine of this angle S, cosine is adjacent over hypotenuse, would be negative square root 5 over 3. The cosine of T, now I'm looking at this guy over here, his cosine would be, let's see, cosine of T would be square root 2 over 2. I'm sorry, square root 2 square roots of 2 over 3. And then we have to do minus sine of S, which they already told us was 2/3. And sine of T, which they already told us was negative 1/3. So this will be what? Negative 2 square roots of 10 plus 2 all over 9. So we could factor the -2 out, and that would leave us with square root of 10 plus, minus 1 all over 9. And that would be our answer. And that's without us even knowing the angles, okay? So that's something kind of nice that you can do if you know a little bit of information, okay? Let's see. I think my notes are out of order. Yeah. Okay. Let's see here. So let me give you guys another one. Let me give you sine and tangent now. So now we have sine of A plus B. Oops, let's do minus first because that's what I did for cosine. And sine of A plus B. Yeah, I think I just want to write this one out because we're not meeting in a classroom. I want to go ahead and give you guys kind of the formulas. So we have the sine of A plus B. That's going to be equal to sine of A cosine of B minus cosine of A sine of B. This one will be sine of A cosine of B plus cosine of A sine of B, okay? So for the sine ones, whatever the sign is, if it's plus, then it stays plus, and if it's minus, then it stays minus. Let me just make sure I didn't talk to myself while I was writing it and write it incorrectly. Sine A cosine B plus cosine A sine B. Yeah, that looks good. Okay, and then I'll also write out the ones for tangent. Tangent of A plus B. Let me do minus first again. This will be the tangent of A minus the tangent of B, all divided by 1 plus tan A tan B. All right, and then tan of A plus B, I'm assuming you guys can figure it out. It's going to be the exact same, but it's now going to have the plus and the minus switched. Tan of A plus tan of B divided by 1 plus, oops, I think I wrote it. 1 minus tan A tan B. I think I confused myself. Let me just make sure. So the plus one, plus, and then the minus. The minus one is the minus, then the plus. Yep. Yep. Okay. So we have these formulas now. So we could be asked to find the sine of 5 pi over 12. Okay. So your job is to think about what angles build 5 pi 12ths. Or you could think more, what builds 5 12ths, and then just throw a pi in there. So 5 12ths would be what? 3 12ths plus 2 12ths? Well, 3 12ths plus 2 12ths, that is pi 6, and that is pi 4ths, I believe. Yeah. So what we could do is we could rewrite this as sine of pi over 6 plus the pi over 4. And if you were to add these, you would get 5 pi 12ths. And then according to the formula, we just take the sine of pi over 6, the cosine of pi over 4, plus the cosine of pi over 6 sine of pi over 4. So all I did was I used this formula right here. I used this one where I said the sine of A, cosine of B, and then whatever ones I did that way, I switch it for the other one, and now I do the cosine of A and then the sine of B, okay? So when we do that, we should get, let me see, sine of pi 6 is 1/2. Cosine of pi 4, so square root 2 over 2. Cosine of pi 6 is square root 3 over 2. And this is square root 2 over 2. So this would be square root 2 over 4 plus square root 6 over 4. So this becomes square root 2 over 1 plus square root 3 all over 4. If you're wondering why we seem to get a lot of the same answers, think about it. You're constantly forcing all of these problems to fit into 30, 60, 90 or 45, 45, 90 because those are the angles you know how to work with. So of course, whenever we do this, we seem to always get the same answers, or maybe not the exact same answers, but we end up using a lot of the same partial, solutions for sine pi 6 cosine, because remember, the unit circle repeats itself just with positives and negatives, right? So yeah, that's pretty much it. That's how we do these style of problems. It's not too bad. Let's try a tangent one then. So let's say we have tangent of, let's go with negative 7 pi over 12. Well, negative 7 pi over 12, how the heck are we going to get 7 pi over 12 and then end up with a negative? Well, let me see. 2 pi over 12 is pi 6. Then we need something that when you subtract from that, you'd get a negative 7. Let me see, if we did 9 pi over 12, 9 pi over 12 and 2 pi over 12 have a difference of 7 pi over 12. Let's try that. So first I'm going to write it as tangent. And if you're having a hard time with the radians, you could convert it to degrees and see if you could get it to work better. Okay, so that would be 7 pi over 12 negative, and that would be the tangent of pi over 6 minus, what is that, 3 pi over 4. Well, that's good. Those are another a good set. So now let's use this tangent formula that has a minus in it. So tan A minus tan B. So I'm going to put the tangent of pi over 6 minus the tangent of 3 pi over 4 divided by, and then we go back up here and we look, 1 plus tan A tan B. 1 plus tan pi over 6 tan of 3 pi over 4. Okay. All right, so pi over 6 would be, let's see here, sine, which would be 1/2 over cosine, which would be square root 3 over 2. So that would be 2 over square root of 3. The 2's would cancel, and we'd be left with 1 over the square root of 3. I'll clean that up later. We know that the tangent of 3 pi fourths, what quadrant is that in? That's in quadrant 2, right? Because it's almost 4 pi fourths. So it's almost pi. So we're in quadrant 2, and in quadrant 2, tangent is negative. So this is going to be negative 1, minus a minus 1, because 3 pi fourths is basically just 45 degrees in quadrant 2. 1 plus, now we know the tangent of pi over 6 is 1 over the square root of 3. We already did it. And tangent of 3 pi fourths is negative 1. So we end up with 1 over square root of 3 plus 1 divided by 1 minus 1 over square root of 3. So we're going to have to clean this up a little bit. What should we multiply by? Let me see here. I think if we multiply by, no, if we don't, let me just clean up the denominators real quick. So let's go up here. So this becomes 1 plus the square root of 3 over square root of 3. I made the numerator have the same denominator. And this becomes 1, This becomes square root 3 minus 1 all over square root 3. So now I'm going to multiply square root 3 over 1, square root 3 over 1. I don't know if that'll help, but let's see what we get. So this will cancel, and this will cancel, this will cancel, and this will cancel. And this will become 1 plus square root of 3 over square root of 3 minus 1. Yeah, it didn't help as good as I wanted. You guys know that you have to rationalize the denominator. Maybe I should have done something a little bit better previously, but we'll see how it goes. Oh, you know what I could have done, actually? Maybe this would have been better. This is a big division bar, right? So what if I just did 1 plus square root of 3 over square root of 3 times the reciprocal, which would be square root of 3 over square root of 3 minus 1. they cancel. Now this is just a more straightforward way. So I don't feel like I rationalize the denominator twice. Now I have to do square root of 3 plus 1. I'm going to use conjugates. Normally conjugates with square roots are the only way to go. So this would be square root 3. Ooh. Let me see here. This would be 1 plus the square root of 3 squared divided by 3 minus 1, which is 2. So this would be 1 plus 2 square roots of 3 plus 3 all over 2. So that would be what? 4 plus 2 square roots of 3 over 2. Cancel, cancel, cancel. That's a 2, that's a 1. We end up with 2 plus the square root of 3. So that's a little bit more annoying. I think you guys can see tangent is a little bit harder. It's not my favorite one to do. In general, stuff with tangent is just harder. So hopefully you guys get the hang of it. It's not the end of the world. It's just a little bit annoying. Let me see. Let's not do another tangent one. Did I already do negative 105? Let's do the sine of negative 105 degrees. Let me have you guys try that one. So give that one a shot, see what you guys can do. And again, you should start feeling like you're getting similar answers over and over, just with different negative signs or something like that. So go ahead and pause the video and give this one a shot. So I might have chose differently than you, but you could have done, I guess, 60 and 45. For whatever reason, I chose 45. Oh no, 60 and 45 wouldn't work unless they were both negative. I guess that would have been fine. I chose 145 or 45 minus 150. So then I have the sine of 45 degrees, cosine of 150 degrees, minus cosine of 45 degrees, sine of 150 degrees. So sine of 45 is square root 2 over 2. Now let's just double check where 150 is at. So here's 90, right? If we add another 60 to 90, we get 150. So that would be right about there, right? So what that means is we actually have, this is actually 5 pi over 6, which is a 30-degree angle basically. If you're saying how much further do you have to go to get to 180 or to get to pi. So if we have a 30 degrees and we're looking for cosine, then we know it is square root 3 over 2, but we also know it's negative because we're in quadrant 2, minus square root 2 over 2 times sine of 150 would be 1/2, but that's positive in that case. So this would become negative square root 6 over 4 minus square root 2 over 4. But we know once again, this is negative square root 2 square root 3 plus 1 all over 4. Okay, or also sometimes I see this, but I think this is a better answer, and that's the one I think the book will ask you to do. Okay, so let me see what else I got for you guys in here. So if we want, there's some expressions. So using these identities to simplify or verify other trig identities, okay? So, oops, that's kind of weird. So one of the things we can do is we could say, oh, what if I had tangent of 45 degrees? Well, tangent of 45 degrees, oops, not tangent of 45, tangent of 45 degrees minus a theta. So I could use this to rewrite this with no angles and only theta by using the sum or difference formula for tangent. So we know for tangent, if we go up here once again, we know for tangent minus, it's minus and then plus. So we're going to do, where are we at here? Tangent of 45 degrees minus tangent of theta divided by 1 plus tan 45 degrees tan theta. But here's the weird part. Remember, the angle they picked in particular does something special. Tangent of 45 degrees is actually 1 minus tan theta. And then tangent of 45 degrees here would be 1. So this would be 1 plus tan theta. So we have created a new style or a new way to rewrite this when you're using 45 degrees in tangent and you're subtracting off a theta. Okay, so this is another way you could do it. We could also create this. We could say, well, cosine of alpha minus beta divided by cosine of alpha cosine of beta equals tan alpha plus cotan beta, right? So we could do something like this. And so in the previous section, we verified identities. I could say verify. Verify that this is an identity. Well, the first thing I notice is this is the cosine difference. So I'm going to do the cosine of alpha, cosine of beta, plus sine of alpha, sine of beta, all divided by cosine alpha, cosine beta, and that supposedly equals tan alpha plus cotan beta. But in fact it does, because all you have to do is you could split it. There's one fraction, there's another fraction. Let's rewrite that. This will become cosine alpha cosine beta divided by cosine alpha cosine beta plus sine alpha sine alpha sine beta. Sorry, I was reading, I was thinking about something. And then cosine alpha cosine beta. And that better be tan alpha plus cotan beta. So now we can clean this up even more. These, I think I wrote it wrong, to be honest with you. Yeah. I wrote it definitely wrong. This is cosine alpha sine beta. Yeah. Sorry about that, you guys. I knew something was wrong. I was like, well, that's too perfect. So this is cosine alpha sine beta, sine beta, sine beta. So now the cosine alphas cancel and we're left with cosine beta over sine beta. This time the sine betas cancel and we're left with sine alpha over cosine alpha. So cosine beta over sine beta is cotan beta. Oops, you know what? Let me write it how they have it. This is tan alpha plus cotan beta. So now this will become cotan beta plus tan alpha equals tan alpha plus cotan beta. And this matches this, and this matches this, and it's addition, so we're good. Check, we verified. So you can use that on those. So there's something else we can do. If we wanted, what if I said that I have the sine of 2x? Okay, well, this is going to lead into the next section. The sine of 2x is actually saying that you're doubling some angle. So in the next section, we're going to talk about the double angle. Well, this is where it actually comes from. The double angle actually comes from the sum or difference formula, because I could rewrite this then as sine of x plus x, right? Because x plus x is 2x. But I could then rewrite this as sine x cosine x plus cosine x sine x. But wait a minute, it doesn't matter the order, right? Because you're adding, and this is basically a sine x cosine x, and this is basically a sine x cosine x. So you have two sine x cosine x. And as it turns out, sine of 2x, the double angle formula, is 2 sine x cosine x. Okay, so this is going to lead us, this is a very important identity. This is called the double angle for sine. So that's going to lead us into the next section. So that's what we're going to pick up with in 7.6. But please let me know if you guys have any questions. Let me just double check and make sure I covered everything I wanted to go over. There's a few more problems we could do. I could show you this one. Some people call these reduction formulas. I don't really think of them that way, but if we were given, so reduction, let me Google and see if there's a better name for these guys. I don't really like this name because I use the reduction in my mind for something else. Let me just double check for you guys. Yeah, that's one way they're called. I use it when I'm talking about something else, but it's a variation of it. So we can have a few reduction formulas. Sometimes you can write things as single variables like I did with the tangent function. So if I gave you this, if I gave you the cosine of 180 degrees minus theta, I could use my sum or difference formula and I could say the cosine of 180 cosine of theta plus sine 180 sine of theta. Now we know the cosine of 180 degrees is -1 cosine theta plus the sine of 180 degrees is actually 0 times sine theta. So this is actually negative cosine of theta. So if you ever want to find the cosine of 180 degrees minus some angle, you could just say that it's negative cosine of whatever that angle is because of the relationship of cosine and how it works with 180 degrees. Okay. There's one for this. If you say the cosine of 270 degrees plus theta, let me see how this one will work. So we'll do cosine of 270 degrees, cosine of theta, minus, remember the sign switch on cosine, minus the sine of 270 degrees, sine of theta. Well, cosine of 270 degrees is basically the cosine of 3 pi halves, which is 0 times cosine of theta. Sine of 270 degrees is -1 times sine of theta. So this just becomes sine of theta, right? Because a minus and a minus becomes plus. So cosine of 270 degrees plus some angle will just be sine of theta. So you could just use that in general to manipulate problems to get them how you want. I kind of showed you the one for tangent as well. I think that's going to do it for this video, guys. Let me just double check. Maybe there's something I'm forgetting. Oh, there's the co-function identities. This is a little extra. So these are definitely identities that you want to write on a little cheat sheet, like on a little note card. Co-function identities, have these next to you. You should keep them when you go on to calculus. One of the biggest weaknesses of students in calculus is knowing their identities and how to simplify. So we have cosine of A, oops, let me do one for you. This is just information. Cosine of 90 degrees minus theta is equal to sine of theta. So if you take the cosine of 90 degrees minus some angle, you can just basically say that that angle, you could take the sine of that angle and it would be the same thing. So the reason for that is you guys know that this is actually cosine. So we could, I guess, establish this identity. We could say this is the cosine of 90 cosine of theta plus sine of 90 degrees sine of theta. And hopefully that will equal the sine of theta, right? We're trying to check that. Well, this is going to become 0 cosine of theta. And this is going to become plus 1 sine theta. So we know that this is equal to sine of theta equals sine of theta. So this is an identity. This is an identity that exists. There's one for sine as well. There's one for cosine as well. But I think I'll leave that to the book to show you guys some of those. Those might even be in the homework. But yeah, you have, I guess, we could do this one. Yeah, I don't want to do the one for tangent. Yeah, I think I'll leave it at that. You guys can get quite a bit from those. But yeah, you know, feel free to, you know, read up on your or use your notes and start making a sheet of identities. You will need it for this class as well as for Calc 1 and Calc 2 and Calc 3. Doesn't come up as much in linear algebra, but in differential equations, yes. Discrete math, not as much. You don't probably use it quite as much until you get to probably some of the higher math classes, some of the upper division or differential equations, stuff like that. And physics obviously uses a lot of trigonometry as well. But yeah, that'll do it for this video, guys. If you have any questions about anything, please let me know in the next meeting.